Good evening. This is Ankita Jana and Zeva Kamal from IIM Indore, and we are presenting our presentation on 3D printing and Tata Steel. Our main theme is changing emphasis from technical benefits to overall business value. Technologically advanced products have a high cost attached with them, hence keeping out of the reach of majority of Indian population. 3D printing can be leveraged to close this gap. We have in our presentation covered 3D printing in depth and explored the possible ways in which it can disrupt the steel industry. In the process, we have proposed to integrate 3D printing in the Tata Steel value chain. From the genesis of 3D printing in 1981 and 1984, it has come a long way. Recently, Strati was the first 3D printed car, and there was a 3D printed unmanned aircraft. It is the next big disruptive technology. Why? Because a lot of major industries are using it. We can see Boeing, which printed 20,000 3D printed parts in 10 different commercial and military planes. We have General Electric, which has 85,000 fuel nozzles, fuel injectors, save $1 million per year, and that too efficiency increased by 15%. We have Hershey's making 3D printing mainstream by using them to print chocolates in different shapes. We have General Motors, which recently printed the 500,000 part. Normal traditional methods they take 4 months and cost around $500,000, but using 3D printing they achieved in 4 days and only $3,000. Even Nike has made 3D printed cleats. In 2015, $11 billion had been spent on 3D printing, and it is predicted that by 2009 it will surge to $27 billion. In 2015, shipments of 3D printers rose by 35%. An estimated impact of $550 billion is by 2025. Industrial revolution. What is an industrial revolution? When everything changes about the industry, and 3D printing is heralded as the second industrial revolution. What are the main advantages? We have mass customization, reduced costs, decreased inventory, innovation, diverse applications, and less waste, all credited to additive manufacturing. And but what are the disadvantages? It is still very slow, speed limitations. It is unpredictable because of its nascent stage. There is high direct cost involved. There is multi-material printing, which is very underdeveloped. And then there is the problem of residual stress. But why is it threatening the current industry? Because it is demolishing the economies of scale. It's dismantling entry barriers and hence threatening that traditional manufacturing may get obsolete. Why? What are the drivers and of 3D printing? It is seen that the cost of 3D printing machine has been going down. There is a shifting focus from design developer to goods producer. So 3D printing is no more just a hobby job. It can be used for mass production. The labor costs are constantly fluctuating in the traditional method. Such things are not associated with 3D manufacturing. And with 3D manufacturing, there are less chances of human error. So what was just a dollar 3.07 billion in 2013 has grown by 33.05% to 12.8 billion in 2018. There is also high growth noticed in metal printing. We can see in 2012 to 2013 alone 75.8% growth, and 2013 to 2014 89% growth. There are only 33.3% of industries which are not implementing 3D printing. Rest all of them are either already experimenting or prototyping or building products. What is the scope of 3D printing in manufacturing? The main scope is it produces parts and assemblies in a single build. It has more efficient designs. You can easily change the designs and experiment because the design is fed from a computer. So all you need to know is CAD. It reduces the need for tooling, machining, and handcrafting prototypes. The printer does it all. It reduces need to maintain inventory of physical models. The associated costs. Conventionally, economies of scale exist. As you go on producing more and more, you can see that this line presents the mass production equation. This shows that as you go on increasing the number of units, your cost drops. But 3D printing, which is your tomorrow, it is just constant. So it demolishes the economies of scale. No matter you produce a small number of products or a large number, the cost remains the same. Costs are not tied to the number of units manufactured, and the cost is low. So the future implications are material and blueprint customization, as everyone chooses 3D printing over mass manufacturing. The cost will go down. Why 3D printing? So the major problems associated with the current traditional method are geometric constraints, inefficient molds, limits of liquid metal, and operators required. We can also see that competition is advancing in this stage. We can see ArcelorMittal, who's a global competitor, our competitor on a global level, is the steel provider to 3 MD3X, which is 3D printing metal bridge in Amsterdam. Why is it doing so? To know what kind of steel can be used in 3D printing. It is already investing there. We also have the threat of substitution of steel. We have aluminium, plastic, graphene, carbon fiber, reinforced polymer, wood, ceramic, and glass. But still, 3D printing will probably prefer steel because it's sustainable. It has many features like strength, toughness, ductility, weldability, durability, and it is efficient. It is energy efficient, cheap, integral to global circular economy. So, what is the solution? The solution is integrate 3D printing of steel in business and benefit from lower cost, greater experimentation capacity, and flexible manufacturing. How to adopt 3D printing? There are 7 categories of 3D printing, but the printing that is most relevant to us is power bed fusion. It is selective laser sintering. So there is a layer of powder bed, and over that the 3D printing melts layer by layer the design that has to be crafted, and every layer in that process is put on the other layer by putting another power bed. But what are the advantages? They're relatively inexpensive, suitable for visual models and prototypes, ability to integrate technology into small scale office size machine. Powder acts as an integrated support structure and can build very complex structures, not possible in conventional methods. You have a large range of materials which is in the powder form that you want. Parts possess high strength and stiffness, good chemical resistance, but there are disadvantages as well. As it goes layer by layer, the speed is relatively slow. Lack of structural properties in materials. Sometimes there is no surface finish, and the mud powder are not that dense, which can lead to porousness. There is size limitations. You can only print a certain size, which is being researched upon. There is high power usage. Finish is dependent on the powder grain size. There is thermal distortion, and there are high levels of residual stresses. But in the end, we can see that traditional manufacturing is just a form of an evolutionary innovation. Every step you increase by adding some features. Whereas selective laser sintering, which uses the power bed fusion, is a revolutionary innovation. It is unpredictable, and you can drastically revolutionize or disrupt the industry using this. So, this is the technology of tomorrow. What are the materials generally used in selective laser sintering? Stainless steel, titanium, aluminium, cobalt, chrome, steel, copper. And here we can see the cost per unit of how the cost per unit varies with the different techniques. We see that injection molding again depicts your uh, economies of scale. We have stereolithography, fusion deposition modeling, fuse deposition modeling, and laser sintering, which are 3 forms of 3D printing. And we see that selective laser printing is the lowest of them all. So, what is the future plan? The thing is, even though there is SLS is very good for production, but it is mostly constrained to prototyping. Only rapid prototyping is possible. So what are the problems? There is low speed, there is post processing requirement, which is the finishing, there is orange peel defect, there is laser application is very costly, and building large product. But the main thing is the cost associated with it is the high laser cost, and this is removed in high speed sintering, which is our proposed method of 3D printing. It makes rapid manufacturing possible. The process includes inkjet printer, powder bed fusion, and infrared lamp, which completely eliminates the cost of the laser. What are the features and advantages of HSS? There is fast sintering, polymers previously prone to thermal degradation can be printed, mass manufacturing, rapid hitting, creating large products, cost reduction, easily recyclable, able to vary material densities up to 40%. As you know that in the infrared printing, we can use different levels of uh, the carbon to make sure that the densities are different. So the future of 3D printing lies in providing endless options for consumers who can conceptualize their idea but don't have the means to create it. Finding optimal mix of traditional manufacturing and new 3D printing techniques. We have to justify the cost of expensive 3D printers. Organization has to be ready for the change. Strategic implications and effect on existing business needs to be evaluated. There have to be a set of formal standards. There has to be in-house additive manufacturing resources. We have to develop capabilities not only in the 3D printing arena. We also have to go for the software part of it, which is basically designing the designs on a computer software. Lack of expertise or training among workforce and employees can be the challenges for Tata still ahead. And how do we combat them? So basically now we are going to suggest what are the industries which can be disrupted by 3D printing. Packaging industry can be is very prone to being disrupted by 3D printing. What is Tata Steel doing now in packaging industry? Tata Steel packaging is an industry, and it is under the brand of Protect. The turnover was rupees 935 crores in the fiscal year 2015. The materials used in the packaging industry are mostly tin plate, ECCS, polymer coated steel. What are the main selling points? Two-thirds of the steel packaging can be recycled, bright, still beautiful, and aesthetically very attractive, unbreakable, and best for preserving. And what are the sectors targeted by Tata Steel at the moment? Beverage, food enclosures, paint and industrial, personal care and household, and promotional. But what are the key challenges that have still not been addressed? You have the perception that packaging is a commodity. Your product, which is packaging, comes under picking, which shows low uncertainty of unused brands and low differentiation. So differentiating your value proposition is very difficult, and coping with just in time inventory. So, how will 3D printing disrupt the packaging industry? It has been forecast that 30 to 50% of complex low volume part could be 3D printed by 2025. If you want complex designs, you go to 3D printing. And as there is no economies of scale and the cost is low, you can always 3D print even low volume parts. So what we predict is by 2016 there will be high level of customization, and by 2020 there will be widespread usage. So what are the key selling points of packaging? Rapid prototyping. Suppose you go to an industry and show the package. Suppose it's a beverage industry, and there is a new can that you want. You want that industry, that company uh, to associate its brand with the perfect can design. You go and show it, and if they don't accept it, then you can change the design. So that is rapid prototyping. Simplified design, conceptualization, proper sizing, and package fit. You can customize it all. What are the types of 3D printing that are used in packaging? Polyjet 3D printed marketing models, FDM 3D printed marketing models. What are the advantages? Mass customization, brand recognition. Now we have the automobile sector. There is high growth in the automobile sector. Why do we adopt 3D printing in automobiles? Because of enhanced experimentation capacity, no additional tooling, shorten the lead time, reduce developmental costs, increase fuel efficiency by making it lightweight. We have seen that nearly constant sales of bearing division, the ball bearing division. So that is our opportunity. Steel makes up more than half the weight of a car, used for the body, chassis, powertrain, gearbox, wheels, and tires. But the challenges associated with it are building large products, combining multiple materials. Limited materials can be 3D printed, competing with economies of scale, quality check, residual stresses. But what we can do is the growing application of SLS in automotive industry can be used for prototyping, and then we can use HSS for building the car. How we can then we have our Tata Shakti Nestin. which is basically the construction industry. Here, the materials used are steel, cement, board, wall insulation. Basically, the selling points are earthquake and fire resistance, beautiful and affordable and environmental friendly. But still, the key challenges unanswered are labor efficiency, skilled workforce is vanishing. There is no control on the construction side. There is low income housing and emergency shelters, which are critical at times. And then it is still largely manual and not automatic. We can see that Tata builds the houses in just 9 days. But how can 3D printing disrupt this industry? By 2017 to 18, there will be a machine for sale for $200,000. By 2020, there will be widespread usage, and it's been predicted by 2025 there will be high rise buildings. How? By using contour crafting, 3D printing a building. The advantages are what Tata could do in 9 days, it can be done within 19 hours, and from a 300 square feet house, it can become a 2500 square feet. It will cost 60% less. What are the applications? Affordable homes, homes for shelter during emergency, low cost buildings in villages. So, what is our proposal? Our proposal is, do we know everything about 3D printing? No, not yet. So, in 2016, our focus will be on R&D. Why? Because 3D printing is in nascent phase, software and hardware still have limitations, material optimization has not been achieved, there is the scope of multi-materiality which is still underdeveloped, there is the problem of surface finish in the metal 3D printed things, and there is the problem of residual stress. What is the solution? We have to invest and collaborate. You have to invest in the researches conducted by leading institutions and new 3D printing companies and probably tie up with them, which is our proposition for the year 2016 to 17. Why? Because you have to create a knowledge base. The current research is going on our low cost open source 3D metal printing. There is MX 3D bridge project which ArcelorMittal is already funding. There is electron beam additive manufacturing by Sayaki. There is automated construction by contour crafting by Behrok Khoshnevis. Now, after you have developed the knowledge base by tying up, the next step is to develop in house capabilities to leverage that knowledge, and that we propose to do by 2019, because you can use this for mass customization, engineering redesign, and shift from mass prototyping to mass production. What are the objectives? We have to optimize the cost, the cycle time, and the quality. So, in nutshell, our proposal is for 2020 and beyond. First, we have to see what goes into the process, the composition of the material, which will ensure proper strength, expected ductility, surface finish, and durability in the finished products. The right combination will lead to the right products. And for every different product, this composition should vary, and Tata Steel should have the knowledge of what kind of materials will go in what kind of products. Then we have the process. What kind of 3D printing are we using? We will use HSS for both packaging and ball bearing and automotive industry, and contour crafting for the construction industry. What is the output? It will be applied to those industries: automobile components, packaging industry, and affordable housing. Thank you, and thanks to our mentor Vasant Subramanian.